everybody. So today's topic is about chromatic aberration. Do you know what is aberration? The defect produced in the image, that we call it as aberration. Defect means how it will form. If we take an object, when we illuminate the object with a white light or monochromatic light, if we use a convex or concave lens, that lenses will form the image of the object. Now, if the image of the object is same as that of the object, then we say that there is no defect in that image, right? If the image formed is same like either in size or shape or position, if it is same like object, then there is no defect. But if there is a deviation in actual size or shape and position as calculated by simple equations in the position of image, we call it as defect. When we will say defect is produced, when there is a deviation in actual size and shape of image compared to that of the object, then we say that defect is there. That defect itself only we call it as aberration. Now then, why these defects are produced? These defects are produced due to light. Here, if we use white light, we get multicolored image. That defect we call it as chromatic aberration. Now, okay, with white light we got chromatic aberration, we said. Now let us use monochromatic light. So after using monochromatic light also, some aberrations are produced. Then why? After using monochromatic light, why aberrations are produced? That is due to optical system. Due to optical system. The aberrations produced due to optical system are spherical aberration, coma, astigmatism, distortion and curvature. So now today's topic is related to the chromatic aberration. Okay. So actually the chromatic aberration is formed due to the reason that refractive index varies with color. The chromatic aberration is due to the fact that refractive index varies with color. Okay. We know that focal length of the lens is given by the formula 1 by f equal to mu minus 1, 1 by r1 minus 1 by r2. Right? R1, R2 are the radii of curvature of lenses. Now mu is the refractive index of the material of lens. F is the focal length of the lens. Right? Now here white light means when dispersion occurs due to refraction, we get or it splits into VIBGR, violet, indigo, blue, green, yellow, orange, red. Right? Now the violet color refractive index is greater than refractive index of red color. So the focal length of violet color will be greater than focal length of the red color. Okay. So when first let us take a convex lens. Right. Now this is the convex lens. This is the principal axis of convex lens, right? Now these are the parallel beam of white light. A parallel beam of white light. okay, parallel beam of white light. When this white light is refracted through the convex lens, it splits into 7 different colors, that is VIBGR. So now here the reason is that refractive index varies with the color. So due to that fact, what happens? Due to that fact, as focal length of the focal length of red will be greater than that of the violet. As focal length of these red rays is greater, they will focus at a farther distance from that of the lens. Let us imagine this. Okay. These are red rays. Now as the focal length of violet is less compared to the red rays, they focus on principal axis nearer to the lens. These are violet rays. Okay. As focal length of violet rays is less, they focus on principal axis nearer to the lens at FV, where FV is the focal point of violet rays. As focal length of red rays is greater, they focus far from the lens, that is at FR, where FR is the focal point or focus of red rays. Okay, and the intermediate colors are present now between violet and red. That intermediate colors, they come at focus between in such a way. They come at focus. They come at focus between FV and FR. So these are the intermediate rays. Intermediate rays. They focus in between FV and FR. Now if we see this diagram, what we are understanding? The image is not perfect at any point. Right? The image is not perfect at any point. Okay. Now let us take a screen. Okay. Let us take a screen. First place at FR no. When you place at FR no, how it will be means at the center. At the center totally red rays are focused. And at outer edges we find violet rays. Now remove this and place at FV. At the center you will see violet rays are focused sharply. And as we go towards the outer edges, the red color will be there. Outer surface will be red. Now just move this screen in between FV and FR. Okay, move the screen between FV and FR. So now you will see the image is blurred, okay, and not perfect. Actually we are using white light, so image must be white only, no? But instead of white, what you got? You got a image where either in a red color or violet color with other colors. Okay, so now here if we move the screen in between FV and FR, the image will be blurred because the image is not perfect anywhere. Okay, so this defect we call it as chromatic aberration. This defect we call it as chromatic aberration. The image of white object, this is white object, no? The image of white object formed by lens, how it is? It is colored. How it is? It is colored. And whether it is sharp? No. It is looking blurred. So, the image of this white object is colored and blurred. Colored and blurred. So, this defect we call it as chromatic aberration. So, this defect we call it as chromatic aberration. Right? Such chromatic aberration, understood about chromatic aberration? So when we use a white object, then image must be white. Instead of white image, what we got some colored image, and that colored image is also not sharp, blurred. Okay, so that defect we call it as chromatic aberration. So chromatic aberration is of two types. One is longitudinal chromatic aberration. Other is lateral chromatic aberration. So first let us see what is longitudinal chromatic aberration. Okay, so let us see what is longitudinal chromatic aberration. Here I am again taking the example of the same convex lens. Now this is some point size white object, right? Now violet rays, as their focal length is very less, they form their image at FV nearer to the lens. As red rays focal length is more, they form their image far from the lens at some FR position. Okay, so from this and the intermediate rays which are present, they form in between these two. So now the distance between FV and FR, we call it as longitudinal chromatic aberration. So from this what we are understanding? We are clearly understanding that the different images are formed at different positions. No, violet formed at FV, red formed at FR. Okay, so the formation of image of different colors in different positions. Okay, the formation of image, okay, the formation of images of different colors at different positions, we call it as longitudinal chromatic aberration. Now let us go for lateral chromatic aberration. Okay, lateral chromatic aberration. Again I am taking the convex lens. Okay, now this is a certain height object I took, AB, right? Okay, so as usual, as violet rays are having lesser focal length, they form their image at some FV, okay, nearer to the axis. As red rays are having greater focal length, they form their image far from the lens. Now this is the image of formed due to violet rays. This is the image formed due to red rays. Okay, AR, BR. Now see the sizes of image. AV, BV is less than AR, BR. Means different images are of different sizes. So here different images are of different sizes. That we call it as lateral chromatic aberration. That we call it as lateral chromatic aberration. The images of different colors are formed of different sizes. that we call it as lateral chromatic aberration. Now next, the magnification. Magnification means size of image by size of object, or distance of image by distance of object, that we call it as magnification. Now let us see, when object is situated at infinity, the longitudinal chromatic aberration is equal to Fr minus Fv, the difference of focal lengths of red and violet. When object is situated at finite distance, the longitudinal chromatic aberration is equal to omega by Fy into Vy square, where omega we call it as dispersive power of lens material, Fy mean focal length, Vy image distance for mean ray, okay, for mean ray. So this is about chromatic aberration, its type and calculation. Thank you for watching my video. If you like my video, like it, subscribe it and share it. Thank you.